Bismillahirrahmanirrahim. Assalamu alaikum. Now, to continue with our discussion on replacing natural aggregate in concrete, uh, nowadays one of the best way is to use recycled concrete aggregate, uh, and it has got many advantages as well. And this is the latest trend, and people are experimenting on it. So I think it's worth to discuss it with you instead of using some other material. There are other materials as well. Some people are replacing plastic waste. Some people are doing fibers. There are many ways. So obviously, uh, for the sake of this course, I'm debating the replacement of aggregate with recycled concrete. This this topic. So let's start with this topic. One of the major challenges of our present society is the protection of the environment. Some of the important elements in this respect are reduction of the consumption of energy and natural raw materials and consumption of waste materials. Rapid infrastructure development such as highways, airports, and growing demand for housing has led to scarcity and rise in cost of the construction materials. Any construction activity requires several materials such as concrete, steel, brick, stones, glass, clay, mud, wood, and so on. However, cement concrete remains the main construction material used in the construction industries. For its suitability and adaptability with respect to the changing environment, the concrete must be such that it will conserve resources, protect the environment, economize, and lead to proper utilization of energy. The utilization of recycled aggregate is particularly very essential as major part of concrete is made of aggregates. Most of the waste material produced by demolished structures disposed of by dumping them as a landfill. Dumping of waste on land is causing shortage of dumping place in the urban areas. Therefore, it is necessary to start recycling and reuse of demolition concrete waste to save environment, cost, and energy. The use of recycled aggregates from construction and demolished waste is showing its prospective application in construction as alternative to natural aggregates. So what are the source of aggregates? The enormous quantities of demolished concretes are available at various construction sites. Many old buildings, concrete pavements, bridges, and other structures have overcome their age and limit of use due to structural deterioration beyond repairs and need to be demolished. The structures, even adequate to use, are under demolition because they are not serving the need in present scenario. Structures are turned into debris resulting from natural disasters like earthquake, cyclone, flood. In, in today's world, a lot of terrorist activities are also contributing to this unwanted waste. New construction is required for better economic growth. Recycled concrete aggregates not only the original aggregates but also hydrated type waste. Recycling of aggregate can take place either at the site from which the material is sourced using mobile crushers, or the material may be transported to a central recycling facility where large stockpiles may be accumulated. Recycled aggregate from these centers recycling facilities undergo a number of processes to ensure higher quality. Various elimination processes involve crushing, resizing, sorting, screening, and contaminant elimination. Then to start with clean quality aggregate in order to meet design criteria easily and ultimately get a quality product, it will go into end use. Further cleaning is also done to ensure the recycled aggregate is free of dirt, clay, wood, plastic, and organic material. This is done by the process like water flotation, hand picking, gas separators, and electromagnetic separators. This is the drawing showing. This is the layout how you can you know get an aggregate in various ways, maybe from 40 to 80%, as low as 16 to 20%, and with the hand sorting you can have 80% plus. So even the magnets can be used, you can use air separator, air separation. There are different percentages to come up. But at the end, after going through even those processes, you do have to end up with hand pickings. That takes time, but obviously the cost of these times will not be as much as of the natural aggregates if you combine it all together. Because in one way you are you are saving your natural aggregates, the other way you are saving the landfills from these unwanted aggregates. So it's a double purpose. So if I as a researcher, I feel even if it is costlier to some extent, but uh, beneficially wise, it's gaining, it's give you a more benefit. So today's world of sustainable society, where natural resources are being depleted. This is one of the way of processes that are now being used to crush, sort, and sort those aggregates. And I don't know how many of you have visited the crushing plants working around the city, around North Karachi and Hub. Please do and visit, because if you have a concept of how natural aggregates is being sorted out, how it is being prepared, you will easily get this concept of recycling aggregates. And these are some of the machines. And this is a crusher actually that crushed your material into your required sizes to smaller particles. And if you are good enough, even in NAD University, there is a small crusher just uh, just behind your transportation engineering lab, where you will see that crusher, and students are even using those crusher for their final projects. Please go and have a look at it. Obviously, after this pandemic issue is over for you and you are allowed to come to the university, I know some of the final year students are still coming, so go and get this perspective also. It will give you an idea how those RCA is being produced even in every university as well. Now, let's try to summarize in how many ways you can use those aggregates. Actually, we can categorize as 14 places. For example, in the given diagram, we say there are number 1, 2, 3. They are all roads where this recycling has been used. And if you look at number 4, it can be used as ground improvement, where is number 4 is like that. And then there is an earthwork embankment, earthwork cutting, shallow foundations, deep foundations, utilities, uh, concrete substructures, concrete structures, buildings, maybe of industrial or maybe of residential. So there are a wide variety of recycling waste that are now being used by put in the practice. Now the problem is you must be sure when say either replacing aggregate or this, it's a replacement. This recycled or other materials may not replace the whole aggregates, not 100%, because there are other limits, and scientists over the years and the engineers over there have found that they have to be replaced with a limited numbers. Though people have even tried for 100% replacement, but ultimately they didn't got anything. In my experience, I've been working with price recycle aggregate for some time as well. The maximum quantity we have gone is 30%. Beyond 30%, you will not get quantity as good as you would like to have. So as the replacement amount increase, there is a problem with dry shrinkage and creep will increase in tensile strength and modularity will decrease. Obviously, if the purpose is not served, you cannot compromise the quality just on the basis of your economics. This is mainly because why it's happening. This is mainly because this recycled aggregate provides less resistance to the movement, lower elasticity modulus, and because of the higher cement contents that are often used in these concrete to achieve the required strength. For doing that, we need sieve analysis according to the standards set forth by ASTM or S2, whatever is your requirement, or maybe from any agency. We need to carry out sieve analysis. This is a very trivial thing. It is found that the recycled aggregates are reduced to various sizes during the process of crushing and by sieving to a number 4 sieve, which gives great mass particle size distribution. So if you use a sieve lesser than that, then you may not have a very good sorting of an aggregate. The particle shape analysis of recycled aggregate indicates similar particle shape of natural or grade aggregate obtained from the crushed rock. One of the things that influences this recycled aggregate is its specific gravity and water absorption, and that's why it was a factor that actually determining us that stopping us to replace 100 aggregate more than 100%, 30%, as I discussed in previous slides. So that saturated surface dry condition specific gravity was 2.35 to 2.58, which are lower as compared to natural aggregates. To remind you, any aggregates having specific gravity more than 2.65, at least 2.65 is considered to be a very good aggregate, and that is also being specified in most of the time in any specification where you are constructing a road or a building. And obviously, with the mortar being attached to the recycled aggregate, the water absorption values are also higher, and it's from 3.05 to 7.4%, which is quite higher than that of natural aggregate. That's why we just keep on supplementing that we may not use recycled aggregate. That recycled aggregate will not replace natural aggregates by what it is being now tested and established like 30%. More not 30% is maximum. Some people say it's 5-10%, it's good. Now the bulk density of recycled aggregate is lower than that of natural aggregate, which results into higher porosity. Yes, this crushing and impact values, they are also have effects on the concrete, and because they are already being subjected to wear and tear first during the demolition and then again with the crushing. So yes, the resulting concrete will not be as stronger as natural aggregate. The compressive strength is according to some standards are being tested at 1, 3, 7, 14, 28, 56, 90 days, and that the result shows that compressed strength of recycled aggregate concrete (RAC) I will use in future is lower than the conventional concrete concrete made from similar mixed proportions. The reduction in strength of RAC as compared to natural aggregate concrete (NAC) is in order of 2 to 14% and 7.5 to 16% for M20 and M25 concrete respectively. Since you are a final year student, I expect you to know this M20 and M25 concrete. Uh, and that's what I don't want to discuss right now. The modulus of elasticity. The modulus of elasticity is lower than the natural aggregates and reduction is to 50%, 15%, sorry. The reason for lower statistic modulus of elasticity is higher proportion of hardened cement paste. NAC is if if the experiment was carried out in which NAC and RAC was most were designed identically, that is 1 to 1.6 to 3.3 in both the case obviously, and in addition to that a fly ash was also used to both type of the concrete, and they also used water cement ratio 0.4 by 8 and water reducing admixture 125 millimeter per 50 kg of batter. Though with my experience, I feel that by 4.4 by weight was a little lesser for RCA, but since this is a research, and obviously I don't want to find out the errors in this. I just want to give you an example how those RCA is being replaced. Now, if you compare the 7 days and 28 strength in megapascals, NAC is 35 point. Just taking a pause for the azan. Okay, I continue. So if you compare this ordinary condition, as you can see, if you are not doing anything, and I suppose that RAC was mixed up to 30%, you find the compressive strength of RAC and concrete is lesser in both 7-day and 28 days. But if you use fly ash 10%, what happened is actually the 28 days strength of RAC has overpassed the 28 days strength of NAC. Means if you are using recycled aggregate concrete, also use fly ash so that it will compensate, it will help improving the strength. So this is how you can always use some other things and some other material to supplement this thing. This may also conclude that if you want to use recycled aggregate concrete, used with some other replacement material as well, like flasher, so that your strength is not compromised. This is the effect on the drying shrinkage. Obviously, RAC curves in terms of have more shrinkage value as compared to the normal concrete, and that's very obvious. And these are the what is the graphical depiction. We say RAC need 25% water absorption. Normally, and then again the RAC water absorption is more as compared to NAC, but with fly ash it has reduced to 5%. So that's why I was saying. And if you compare NAC on the left and RAC on the extreme right, you feel that if you add 10% fly ash, the, the shrinkage value, the water absorption value is more or less same. So that's the advantage. One is the compressive strength, and then so this adding RAC with fly ash will give you something equivalent to natural aggregate concrete, as depicted from this diagram, this data. Now, why we have a low strength? That's the weaker interfacial transition zone between aggregate and mortar due to recycled aggregate having a coat of weak mortar already attached, which raises the porosity of the concrete. The inclusion of weak and porous aggregate, for example, low strength bricks, glass, and plaster. Crushing and impact values also depends on the source of originate received from the recycling of aggregate. And last but not least, compressed strength depends on the grade of the demolished concrete, replacement ratio, water cement ratio, and the process of the recycling. What are the obstacles? Why people are still deterrent to use RC? Application, technical reasons such as weak interfacial transition zones between cement paste, aggregate, porosity, and transverse crack within demolished concrete, high level sulfate and chloride contents, impurity remains, cement remains poor, grading, and large variation quality. Current resistance experience are not adequate to support and encourage recycling construction, demolished waste. This is not in India, but as well all over the developed, whatever underdeveloped countries like Pakistan, Sri Lanka, Bangladesh, like that. There's a lack of awareness, guidelines, specifications, standards, database of utilization of RCA and concrete, and lack of confidence in engineers. Researchers and user agencies in major cause for poor utilization of RCA and construction. So I can safely say it's still in the experimental stage. So though in a few slides I will give you the practical examples of those RCA, but still this is in its infancy, I would say like this. What value this adds? RCA reduces the need for virgin aggregates, then reduces the environmental impact of the aggregate extraction process, produce specification size recycled aggregates at any given location, avoid haul of cost and landfill cost proportion, eliminate the expense of aggregate, minimize impact to community infrastructure by reducing import and export. So this is the case study. A building was constructed, recycled aggregate, and it's in its place. The good thing is that, and then this is what city of Melbourne. There is a builder, architect, structural engineer. 10-story building was constructed, 2000 there, and it's still there. So this is a live example what where RCA has been used. This is another view of that building. And then there are some other structures. So you see, this RCA is being used with confidence in developed countries, but now we have to step up and start recommending this. So it was just like, the totals was 7262 cubic meter was concrete was used, 100% of the quantity of 63% replacement, percentage of project cement replacement 27, and the green star they have recommended there was 75% good, and that need to be 30%. But these are exceptions, but the building is 10. This is the main point. So that concludes my presentation of recycled aggregate, and I think I have just covered this topic of replacement of materials in concrete. So next time I will talk about some innovative technologies like trench-lip technologies. So thank you very much, and again I feel I'm confident that this presentation is explained to you in a better manner. Thank you and Allah Hafiz. Take care.